morning, students. Physics, 12th English medium. Topic: current, electricity. Okay, in your NCERT textbook, it is chapter number 3. Current, electricity. What do you mean by current, electricity? Current means flow. Electricity means charge. Okay, flow of charge. Okay, so yes, first topic of 12 is electrostatics, in which we have discussed about behavior of stationary charges. Now in this lecture we will see when charges are in motion, what happens. Okay, yes, we have already covered topics in theory in NCERT textbook. Okay, about electrical conduction, Ohm's law, and resistance. So yes, you have to remember each and every concept and equation. Okay, now we will see its application. Means if you are given one question regarding electric conduction, Ohm's law, resistance, then how to solve such questions. See, first question: an electron in the hydrogen atom is revolving around nucleus in the orbit of radius h square upon 16 pi square m e square with speed 4 pi e square upon h. The equation of electric current is. Now see, here you have to remember, yes, sir, equation of electric current. Is there only one equation? No. See, for if charge flowing is constant, okay, anytime, okay, the rate of flow of charge is constant, rate of flow of charge is constant, okay, then for that steady current, we have equation of current, that is I is equal to, it is Q upon T. Yes, you can use this equation when this Q is constant. When this Q is constant. Second, when Q is not constant. When Q is not constant. So to solve such questions, you have to use equation of current, that is I is equal to, it is the Q upon T. Okay, so yes, first equation, that is I is equal to Q upon T. Charge Q flowing in time T. Here I is equal to, it is rate of change of charge flowing, because Q is not same, if it depends on time. But in this situation means when charges are moving on circular path, they are moving on circular path, then what is equation of current? So see, in such cases, whenever charges are moving, they are flowing on circular path, you have to use this equation. Okay, I will modify this equation, that is I is equal to, it is Q upon T, capital T. That is time to complete one rotation. That is time to complete one rotation. Okay. So I is equal to, it is Q upon T, where capital T is, yes, periodic time. Yes. Okay. So Q upon T. Now Q, see, you are given an electron in hydrogen atom. So you use this Q. You have to replace by E. T, we know that for one rotation, we know that speed V is equal to, it is 2 pi r upon T. For one rotation, we know that V is equal to 2 pi r upon T. So if T, then T is equal to, it is 2 pi r upon V. 2 pi r upon V. So yes, you have to remember this equation. Or as it is Q upon T, you know that T and frequency, periodic time and frequency, they are reciprocal of each other. Okay, so you can also remember this equation as QF. Yes, is equal to, you can also remember as QF, where F is frequency. Clear? So see, these are equations for electric current. Okay, for electric current, I is equal to Q by T. When Q you are given constant, okay, K in 10 second 50 coulomb charge is flowing. So simple, this equation. But if you are given okay, q is function of time, q is equal to 5t square plus 2t plus 5, then what is electric current at particular time? Then you have to use this equation. Next one is when charges are moving on circular path, then this equation or this equation or this equation. It depends on data given. Okay, which equation you have to use. Here you are given data in terms of radius and speed. So obviously you have to use this equation. Okay, I is equal to, yes, here in this case I is equal to, it is EV upon 2 pi r. So is equal to, it is E upon 2 pi. Chalo V, where is V? Yes, V is here, it is 4 pi E square upon H. 1 upon R, 1 upon R means it's reciprocal, so it is 16 pi square M E square divided by H square, divided by H square. Okay, so yes, it is equation. Now you have to simplify this. Okay, you have to cut some values. Clear? So again, I is equal to Q upon T. If you make T a subject, then T is equal to, it is 2 pi R upon V. E as it is, 2 pi as it is, V means here it is given V, that is 4 pi E square upon H. 1 upon R means this reciprocal. Here it is. Clear? Okay, now you can easily simplify this one. You can easily simplify this one. Okay? Okay. So yes, it is one question which is based on electrical conduction, that is electric current. Second question. Second question. What is second question? When the current I is flowing through a conductor, the drift velocity is V. If 2I current is flowed through the same metal but having double cross-sectional area, then drift velocity. Now see, underlying terms which you are given. First of all, you are given current, then you are given drift velocity. Okay, and then you are given a third one, that is yes, cross-sectional area. Cross-sectional area. So first of all, identify relation between these quantities. Do you have any relation between these quantities? Yes, we know one equation. Okay, that current density J is equal to, it is NQV. J is equal to, it is NQV. And yes, we know that current density J is equal to I upon A. And yes, J is equal to I upon A. So I can write I is equal to, it is NQV A. As you have to find drift velocity, make drift velocity as subject. So therefore D is equal to, it is I upon N Q A. V is equal to, it is I upon N Q A. Okay? Yes. Okay. So chalo, V drift velocity, I current. What is N? N numbers of electron flowing per unit volume. Q means Q means charge, and A that is cross-sectional area. N is numbers of electron per unit volume. N is numbers of electron per unit volume. Now what you are given? Okay, if current 2I is flowed through the same metal but double cross-sectional area, means current is doubled and cross-sectional area is also doubled. Hello. Current is doubled and cross-sectional area is also doubled. So how drift velocity depends on current and cross-sectional area. To make relation, V is equal to I upon N Q A. So we can say V is proportional to I upon T. V is proportional to, here it is I upon A. Yes, V is equal to, it is I upon A. Now current is doubled and cross-sectional area is also doubled. Current is doubled and cross-sectional area is also doubled. So what happens? Okay, here V dash upon V is equal to, V dash upon V is equal to, it is 2I upon I 2A divided by. Clear about this? Okay, V dash which is 2I upon A. wait a minute. V dash upon V. V dash means you can write final, that is 2I upon 2K. 1 upon V. 1 upon V means initial condition you are given, it is I and V. Then how to write? Then yes, you have to write it is I upon, it is I upon A. It is I upon A. Clear about this? Yes. V is proportional to I upon A. V dash means in final case. In final case, current is doubled and cross-sectional area is also doubled. But in initial case, V is equal to V is proportional to it is I upon A. So A cut, I cut, 2 cut. Then V dash is equal to it is V. Yes. V dash is equal to it is V means drift velocity remains the same. Yes, drift velocity remains the same. Okay, so you have to check dependence on which quantity it depends actually. Clear about this? Okay, now we will see next question. Now next question, see, a wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes. Okay, see how to solve such questions. Here it is. Okay, I need some more space, so a wire of certain material is stretched slowly by 10%. Now what is meaning of this? Stretch means its length increases. Its length increases. Now as wire is stretched, yes, its length increases, but its cross-sectional area also decreases. And yes, its cross-sectional area also decreases. So first of all, what is equation? Okay, what equation we have to use? See, here it is. R is equal to rho L upon A. We know this equation. R is equal to rho L upon A, where rho is specific resistance, L is length of conductor, A is cross-sectional area of conductor. Here we cannot write directly that R is proportional to L. No, we cannot write this. Why? Because if you want to write R is proportional to L, then rho and A, they both must be constant. They both must be constant. Yes, here rho is constant. But in case of stretching, cross-sectional area is not constant. As length increases, cross-sectional area decreases. So here we cannot write directly in case of stretching. In case of stretching, we cannot write this thing directly. Okay, so how to make relation? See, here it is. R is equal to it is rho L upon A. Yes, it is rho L upon A. Yes, it is equation. Now I will multiply this by L and L. Yes, numerator and denominator both multiplied by L and L. So it is rho L square upon A into L. A cross-sectional area, L is length. Yes, you know A into L, it is nothing but V. Okay, so now in stretching process, yes, length increases, cross-sectional area decreases, but volume, initial and final volume remains the same. Yes, volume remains the same. Okay, now here rho and V, they both are constant. They both are constant. Here in case of stretching, A is not constant. A is not constant. Clear? So now as rho and V, they both are constant, I can write K R is proportional to L square. R is proportional to L square. Clear about this? Okay, R is proportional to L square. So this relation you have to remember how to make relations. Okay. Now, a wire of certain material is stretched slowly by 10%. Means if I am assuming initial resistance R1 is equal to R, then R2 is equal to it is R plus 10% of R. So is equal to it is R plus 10 divided by 100 R. 10% means it is 10 divided by 100. So it is 0 cut. It is I think 0.1 R. Means it is 1.1 R. Means it is 1.1 R. Clear about this? Hello? Clear about this? So what is new resistance? Okay, new resistance R2 is equal to it is 1.1 R. New resistance R2 is equal to it is 1.1 R. Okay, yes. R1 is equal to R. R2 is equal to it is R plus 10% of R. Okay. Okay, sorry, this relation is given for length. This relation is given for length. Okay, its length increases by 10%. So yes, how to write? L1 is equal to L, L2 is equal to it is L plus 10% of L. Yes, so it is L. So L2 is equal to it is 1.1 L. Clear about this? Okay. Slowly stretch by 10%, it means its length increases. So if L1 is equal to L, then L2 is equal to it is L plus 10% of L. So it is L plus 10 upon 100 divided by L. So it is 1.1 L. Now we know that what is relation between R and L? What is the relation between R and L? Yes, R is proportional to L square. So therefore, R2 upon R1 is equal to, what is R2 upon R1? R2 upon R1 is equal to it is L2 upon L1 whole square. L2, it is 1.1 L upon L whole square. So L cut. So therefore, R2 is equal to 1.1 whole square. What is 1.1 whole square? Yes, it is 1.21. Okay, R1. So yes, it is your answer. Okay, R2 is equal to it is 1.21 R1. R2 is equal to it is 1.21 R1. Clear? Okay, by mistake I have written it is resistance, but as it is stretched, its length changes. Okay, so sorry for that. L1 is equal to L, L2 is equal to 1.1 L, then R2 is equal to it is 1.21 R1. 1.21 R1. Clear about this? So yes, what is your answer? Okay, new resistance. So new resistance becomes 1.21 times. New resistance. It becomes 1.21 times. But specific resistivity, specific resistance. Specific resistance means resistivity. It remains. Clear about this? So yes, it is one question which is based on relations. Okay, how to solve question when it is one case of stretching. See, stretching and cutting, it is different. Okay, so yes, 3 questions. You will see some more questions now. Okay. Okay, next question. See, here it is given. A wire is bent in the form of circle of radius 2 meter. Resistance per unit length of wire is 1 upon pi ohm per meter. Battery of 6 volt is connected between A and B, and angle AOB is equal to 90. Where is A? Okay, it is A, it is O, and here it is B. Okay, AOB is 90. Find current through battery. Now what is equation of current? Okay, so yes, we know that equation of current I is equal to, it is equation of current I is equal to, it is V upon R. I is equal to, it is V upon R according to ohms. I is equal to, it is V upon R according to ohms law. That is 6 volt given. What is R? Now see, here you are given. A wire is bent in the form of circle of radius 2 meter. Resistance per unit length of wire is 1 upon pi meter. Battery of 6 volt is connected between A and B. Here it is A and here it is B. So see, as battery is connected between A and B, this circle we can divide in 2 parts. First, this one. This big part, okay, and then this smaller one. Yes or no? Yes, it is. Okay, so Two ends of this big arc, A and B. Two ends of the small arc, A and B, means you can say that these two parts, they are in parallel connection. They are in parallel connection between A and B. So first of all, you have to find what is equivalent resistance between A and B. Yes, you have to find this. Okay, what is equivalent resistance between A and B? So for that, see, a wire is bent in the form of circle of radius 2 meter. So first of all, what is circumference of circle? Okay, so it is 2 pi r. So is equal to 2 pi r means yes, it is 2 meter. So it is 4 pi. Now what is resistance of circle? Resistance of circle. What is meaning of this? Okay, resistance per unit length of wire is 1 upon pi. Resistance per unit length 1 upon pi. Okay, so it means for 1 meter length resistance is 1 upon pi. For 2 meter length 2 upon pi. For 3 meter length 3 upon pi. 4 upon pi, etc., etc., etc. So what is resistance of circle? Resistance of circle is equal to, what is length of circle? It is 4 pi into 1 upon pi. Clear about this? So see, this pi cut. So resistance of circle is 4 ohm. Means this whole circle, okay, this whole circle, its length is 4 ohm. Now it is easy. Why is it? See, you are given that this angle AOB is 90. So if you divide this circle in 4 equal parts, and if you divide this circle in 4 equal parts, each and every quadrant will have resistance 1 ohm. See, resistance of circle, this whole circle, this whole circle is 4 ohm. So it means resistance of this part 1 ohm, resistance of this part 1 ohm. 1 ohm and 1 ohm. So for this big arc, what is resistance? 3 ohm. And for this small arc, what is resistance? 1 ohm. So what is equivalent resistance between A and B? Equivalent resistance between A and B. R is equal to it is that parallel connection, and yes, you know that parallel connection. Okay, it is 3 into 1 upon 3 plus 3 into 1 upon 3 plus 1 means it is 3 by 4. It is 3 by 4. Clear about this? Clear about this? Okay. Now you are given this one. Okay, now you have to find current. So current I is equal to it is V upon R. So V is 6 volt and R means it is 3 by 4. 3 into 2, 4 into 2, it is 8 ampere. So this here I is equal to it is 8 ampere. Clear? So you have to understand meaning of this verse, this statement, that is resistance per unit length of wire is 1 upon pi. Resistance per unit length of wire is 1 upon pi. Clear? So yes, this one is a question, okay, which is based on Ohm's law. Okay. Now next question, see. A block has dimensions 1 centimeter, 2 centimeter and 3 centimeter. Ratio of the maximum resistance to minimum resistance between any point of opposite faces of block is. See, I am assuming, okay, suppose A is equal to 1 centimeter, B is equal to 2 centimeter and C is equal to it is 3 centimeter. Okay, you have to find ratio of maximum resistance to minimum resistance. Now what is equation of R? We know that R is equal to it is rho L upon A. So R is directly proportional to L and inversely proportional to A. So for R maximum, rho L must be maximum and A should be minimum. Yes or no? Now with the help of trial and error method, you have to identify okay, for which combination length is maximum and area is minimum. See, I will write here it is A is equal to, it is rho C divided by AB. Yes? C is equal to 3 meter and A into B is only 2. Right? Yes or no? Yes. So for R maximum it is rho C upon AB. For R minimum, rho, material is same, so resistivity remains same, okay? So yes, R minimum is equal to, it is rho. Now, smallest length, see, R minimum, what is its equation? It is L minimum upon A maximum. So it is equal to rho. Chalo, L minimum, with length is minimum, it is obviously A. And which area is maximum? Obviously it is BC. And here it is BC. Clear about this? Now you have to find the ratio. So therefore R maximum upon R minimum. Where is R maximum? Here it is. Rho C upon AB. And R minimum means I can write the reciprocal of this. BC upon rho A. Rho cut. Then yes, B cut, here B cut. Then is equal to, it is C square upon A square. C square upon A square. So C square, 3 square it is 9. And A square means this one, so it is divided by 1. So R maximum upon R minimum is equal to, it is 9 divided by 1. Clear? So yes, you have to think, okay, from equation for maximum resistance, L is maximum and A is minimum. Then for which combination it is possible? Clear? You have to think actually, okay? Clear about this? So yes, for this lecture, 5 questions, they are enough. In next lecture, we will see some more questions. Okay? But for today, this is it. Okay? You have to write this in your good book. And yes, you have to try MCQs, so there are MCQs from different material, okay? As a preparation. Clear about this? This is it for today.